In this lesson, we will look at how to draw Lewis dot diagrams for molecular compounds. Drawing Lewis dot diagrams for molecular compounds is a bit more complicated than drawing Lewis dot diagrams for ionic compounds, so it's best to follow a few steps. First, count the total number of valence electrons available. If any of the atoms involved in the bond are charged, then you must add or subtract accordingly. Second, lay out the molecules in the correct order and draw in the shared electrons. Lastly, distribute the remaining number of available electrons between the atoms to achieve full octets. Let's take a look at H2O as our first example. To begin, we'll count the number of valence electrons. 2 hydrogen atoms with 1 valence electron each, plus 1 oxygen atom with 6 valence electrons gives us 8 total valence electrons. We can now move on to drawing. Since both hydrogens will bond to the oxygen will be placed in the middle, with shared electrons between it and the 2 hydrogens. In Lewis dot diagrams for covalent compounds, shared electrons will be represented with lines. Now that we have used 4 of our available valence electrons in sharing, we can take our remaining valence electrons and distribute them. In this case, hydrogen is already full with 2 electrons, so all 4 remaining electrons will go to oxygen, giving it a full octet. Let's now take a look at carbon dioxide. Again, we first count the total valence electrons, and in this case, we have 16. Following our previous example, using 4 electrons for 1 bond with each oxygen, we have 12 remaining electrons. This allows us to give both oxygens full octets, but does not leave enough for carbon to receive a full octet. Thus, this can't be the correct formation. In this case, a double bond will be needed. In adding a double bond, the carbon now has 8 electrons, as well as both oxygen atoms. Our last example is molecular nitrogen, or N2. For this compound, we have 10 valence electrons to work with. If we use a single bond, both nitrogens only receive 6 valence electrons, not providing them with a full octet. Thus, this can't be the correct formation. If we add a double bond instead, the nitrogens now have 7 electrons, which is still not the ideal octet. In this instance, a triple bond is necessary. This gives both atoms the desired full octet.